Welcome to the Neutral Podcast, where we discuss paving the way to a sustainable tomorrow. I'm Nate Helbach, your host, founder, and CEO of the Neutral Project, a sustainable real estate development company. Join us each week as we host world-renowned guests and explore dynamic landscapes of real estate development, alternative investing, sustainability, forestry, urbanism, and new cutting-edge carbon-neutral construction materials that are shaping the cities of tomorrow. Welcome, everyone. This is Nate with the Neutral Podcast, and we are joined today by Andrew Waugh, who is founder and director of Waugh Thistleton Architects, based out of London, who are pioneers of tall timber. And funny enough, it's Waugh Thistleton's 20th anniversary of building a mass timber building. Andrew, a few questions I wanted to start off with was, how did you get into mass timber and what interested you into the product type?
Wow. Well, it's one of these questions where you feel like if you could kind of post-rationalize the reason as to why you go into it, then that would maybe sound like your career was a lot more coherent than careers ever are. The reason I got into it is because we had a really difficult little job, which was in the back garden of a heritage building. We had a planning consent for a 3-story extension to a heritage building. And, I had this image of all these builders, contractors going through this beautiful kind of 18th century building, carrying bits of timber through, bits of steel through, whatever. And I thought it would be amazing if we could prefabricate it and just kind of drop it into the garden somehow, by helicopter or something. But then actually, we met this guy who had this kind of Austrian timber product, who was talking about prefabricated walls and floors, and so started a conversation with him. And about 2 months later, literally 2 months later, we were watching a 3-story building being craned in, floor, wall, roof being craned in, and it took about 2 hours to build the building on a Saturday afternoon. And I sat in my car with my little girl and we just watched it being built, and it was just fantastic. It was just millimeter perfect and totally quiet and completely accurate. And I just fell in love with with that way of building and that idea of kind of prefabrication and of kind of, what we drew on our drawing board was exactly what arrived on site. The immediacy of the process just was really alluring and exciting. And then the more I looked into it, the more that we talked about it in the office, the more we realized what the kind of benefits were in terms of sustainability and low carbon and efficiency and no site waste, and it's very quiet. And then the buildings are really good for you and they're great to build and great to live in and work in. And then boom, you've got a career.
That's awesome. And that was the building that was 20 years ago.
Yeah, 20 years ago. And now we're 30 buildings completed. And we have a practice that's really dedicated to low carbon construction in general, but specifically to timber buildings, because that's the answer that we have found as a practice to building low carbon. And so we have a practice that designs every building to be a timber building. We have about 20% of our turnover as a practice is pure research. So at the moment we have research projects in the US for the Forestry Service, for National Science Foundation. In the EU, we have them 2 for the European government at the moment, one for the Loudest Foundation through their Built by Nature program, one for the UK Department for Education, another for UK Department Network Rail. So yeah, lots and lots of different research projects which feed back into our kind of design philosophy, design kind of ethos and purpose as a practice.
That's awesome. And what is it about mass timber that makes it so sustainable?
Well, because, simply because most trees and, all trees are made of carbon. And so beautifully, this kind of nature's kind of carbon reduction machine is the tree, and it soaks up carbon dioxide from the atmosphere, releases oxygen for our healthy planet, and retains the carbon within the body of the tree. So the European spruce tree is about 54% carbon. So not only is it a low carbon material to produce because You don't have to melt it or burn it for 3 days like you have to with cement. You're going to the forest, cutting it down, stripping down the bark, and processing the tree. So it's a very low carbon process. It stores carbon. It's in the body of the material, and it's very lightweight. So it's easier to transport, and it has fewer foundations. Essentially, it's replenishable. You cut them down, you grow more. Very unlike any of kind of like natural resources, that create cement and then concrete and steel, which is using natural resources. And in the case of concrete, really hard to reuse that material, really energy intensive to use that material. And every time you use it, it's downgraded each time.
That's awesome. And so it's not just that the actual mass timber is sustainable, you're also able to design less foundations and less concrete into the building, reducing the harmful impacts of concrete on a structure.
Absolutely. And also, it's really, because it's all prefabricated, it's incredibly airtight once you get it on site. So, so it actually, it's a really well-functioning building as well. So that airtightness and that precision allows for the precise purchase of other materials. And it also means that when you live or work in that building, it's not kind of drafty. You're not losing heat through gaps and stuff in the materials.
Yeah, so let's talk about that a little bit, about how mass timber is kind of a componentized system of parts that you're able to assemble versus, using traditional construction materials like steel and concrete. What have you seen from the last 20 years of your experience kind of be a trend for mass timber? I'm sure that first project you worked on, there wasn't as much componentization involved versus now what you're working on with these bigger buildings. And so how is that kind of like componentization and systemization grown over the last 20 years?
Yeah, that's a great question, Nate. It's the first building we built, the wall panels and the floor panels were exactly the same. It was just a very basic material. There was one manufacturer, and they supplied a panel, one which was 3 layers and one which was 5 layers, but all the kind of laminates were the same thickness, and you use the same for the walls and for the floors. So it's a really simple process. And actually, in terms of a kind of construction process, it was more akin to like model making. Do you know, it's just like buying a sheet of cardboard and cutting it up, right? It felt like that, like model making at scale, at full scale. And now that we're learning about the design process of these buildings, we're learning about the idea of an architecture that is engineering led, that you're designing from the inside out, that you're really thinking about each element of the building as a kind of precious object that is designed, as you say, Nate, as a component within that system. So I think that the process, what we thought at first, because you look back in history at architecture, right? You look back 100 years ago, which was the last time that any kind of important transformation happened in architecture with the invention or the rediscovery of reinforced concrete. And you look at where we are now 100 years later, and you think, well, the next kind of big event in architecture will be something that's really about a very different aesthetic. Actually, I think it's more about a different process than it is even about the end result. So the process of how you design and what you consider successful are really in a process of flux. And so for us, we're really learning how to do that as a practice, learning how to think about componentized design, learning how to think about, the process of design in a different way from the one in which we were taught. And that's really fascinating.
Yeah. And when you talk about like process of design, what changes when you're designing like a mass timber building versus a traditional, let's just say, concrete building?
So I think when you're designing a traditional concrete building, in many ways, concrete's a lot more flexible. It's a wet material that you pour into molds, right? So the first building that you build in a concrete building is a wooden one, and then you fill it full of concrete, and then you take that, then you take the first building off the second building, and then you clad it with a third building, whereas timber, each piece that you use is your finished component. I mean, I remember when I was at architecture school, first year, and I suddenly found out that all those beautiful kind of Miesian buildings, all those amazing kind of SOM towers, that the kind of profiled steel on the outside of the building was not in fact the structure at all. It was just bent bits of aluminium to look like steel. And I suddenly thought, oh my God, I've been cheated. Like, these people have been lying to me, and so for me, there's a celebration of that natural material, of the timber itself being the structure and being the celebration that is, that is really honest. And I think that to celebrate that through the process of design is something completely different. So when you're designing a concrete building, I think you're often designing, or a steel building, because it can do pretty much what you want it to do. You're designing from the outside in more often, so it's like, how does it fit? What's the biggest it can be? What do I want it to look like? What's the latest kind of aesthetic sort of demand from client or architecture profession or whatever, what's in, what's out, designing it to that kind of, I find it hard to think about designing buildings like that. It's so awful.
I think if you think through like the design process of concrete versus the design process of wood, I think what I've seen is it's much different. There's a lot of differences between the two. And It seems like there's much more accuracy actually when it comes to timber, because with concrete, you're able to really kind of screw up sometimes in the design, and you're able to make those mistakes, and on site, they're able to fix them relatively easily. But I think one of the things that we've seen with our Baker's Place projects is like, we're not able to change any bathroom locations or any HVAC locations because you have all these pre-run and pre-drilled MEPs that are done in the factory. So it's like, once the shop drawings are complete, then you're pretty much set. And what you get is what you got.
No, timber buildings, are a very kind of careful, accurate, precise process. It is a sophisticated process. You look at the tools of a carpenter compared to the tools of a concrete, installer, no jackhammers or grinders or cement mixers. We're talking about accuracy and kind of, and perfection, and which is just so much more of a rewarding process to be in. You go to a concrete site now, and we've got a couple in the office, which we started as timber buildings and have been built out for one reason or another in concrete. And, the process feels quite Neanderthal, quite sort of like, quite, as you say, quite kind of clumsy. And it feels like when you're building with timber, it feels much more of a much more precious material. It feels like you're dealing with a commodity. I love going for walks in the forest. I don't take cutting down trees and using timber lightly. It's really important to me that we make the most of the material that we use, that we always use as little timber as we possibly can, right? There's cost efficiency there, but there's also carbon efficiency there, and there's kind of planet efficiency there, right? We need to be really efficient with our resources. We call it in the office, we call it an architecture of sufficiency. This idea that we do what's sufficient, we celebrate what's sufficient, and we don't look to add to that. We don't look to use what's unnecessary in that.
Mm-hmm. Yeah, that's awesome. Talking about like efficiency and sustainability, I know your office has been working on some cool things around lifecycle assessments. For our audience, some people might not know what a lifecycle assessment is, so maybe you could give a little bit of context on what a LCA abbreviation, and also what you guys are doing around mass timber and then also buildings.
Yeah, certainly. So the life cycle analysis of a building looks at that building from its inception over a 60-year period, typically a 60-year period, to its notional end of life. And during that period, how much energy, how much carbon is used by that building, is used in its power, its heating, its lighting, its air conditioning, but in the construction materials and in the process of construction. So if you look back in the 70s at a typical multi-story, multi-family residential building, then probably 2/3 of the carbon of that building used over its 60-year life would have been through the heating and the air conditioning, right? And now if you look at it, because we've got insulation, because we've got double glazing, because we're decarbonizing our grid, we're getting more efficient, we have solar panels, we have geothermal, we have all that kind of thing. Now when you look at it, you look at the same type of building, now you look at the life cycle of that building, the carbon used in that building, and probably 2/3 of the carbon of that building are now the building materials and the construction process. So what our job is at the moment is how we can reduce the carbon burden of the building materials and of the building process. And in the UK at the moment, about 25% of our emissions in the UK are purely down to construction. And
Wow.
It's a lot, right? And we don't really, in the UK, we have no legislation governing that. So we have other criteria for investment, et cetera, that looks for low carbon, that asks those questions, but we don't have any legislation around it. So it's very important to us that we can declare these LCAs and that we can show actual measurements, distinct measurements of how our buildings are improving and, making decisions, design decisions, material decisions, where we can show the impact of those LCAs. Now, for lots of practices, those kind of life cycle tools are available to them within their kind of drawing software packages, right? So you can plug into a Revit or to an ArchiCAD, different kinds of software that will help you do that. But in our office, we've got a specialist that does it in the office.
Cool.
I'm looking over him waving right now. He said his name. So we have Tor in the office, and Tor does that. So we kind of get right down into the detail of it. So, and that's many, we just finished an office building for Blackstone in the City of London. It's a 50,000 square foot office building. And we looked at every component within that building. We looked at what the energy performance declaration. So like when you buy a washing machine or you buy a stove or something like that, it has on the back of it an energy performance declaration. Every material has that too. So we find out what the EPDs are for those materials. We look at how far they were transported. We look at what they were fixed with, all of those things. And then we look at what the kind of like the entire building looks at. So that's like it took about 3 months to study that in real detail. But it's so fascinating. The other problem that we have currently with timber is that all the people that accredit the life cycle analysis of buildings, they presume that the timber that we use in buildings, after that building is demolished, that timber gets burned or it gets buried in landfill. And that once burned, it either creates carbon, the carbon goes back into the atmosphere, or it creates methane when it degrades in landfill, right? So that's counted. So that always makes the life cycle analysis of timber buildings not look perhaps as rosy as they can. So the other thing is we're working with the European government at the moment, the EU, to look at how we can reuse mass timber in the future. And so by demonstrating the opportunities of reuse, by talking to the manufacturers about taking back mass timber after the end of life of the building and repurposing that mass timber to be used again, we can then reduce the energy performance declarations and the life cycle analysis of that material. And we can demonstrate that our buildings are even greener than we know that they actually are. Does that make sense?
Yeah.
I get quite excited about this stuff.
Yeah.
But you know what, Nate? Honestly, all I ever wanted to do was make nice buildings.
Yeah.
That's still what I want to do. But in order to be able to get the short distance in my mind from A to B, I have to kind of learn a lot about other stuff and go and take some quite circuitous routes in order to be able to kind of demonstrate the purpose of our intent.
That's awesome. So if I can dig in maybe to a little bit on this life cycle assessment that you're talking about. So when you guys are studying it, my understanding is you're looking at a few different stages of the basically life of the mass timber. So you're starting with the raw material when it grows in the forest. Then you're taking that raw material and you're putting it into the manufacturing facility to actually make these CLT. And then from there, you're transporting it to site. And then it's the use phase and you're using that mass timber. And what you guys are studying specifically is we know those first 4 stages relatively well, right? We can quantify those stages. But maybe what we can't quantify right now or don't really understand because mass timber is such a new product is how do the mass timber actually go through the end of life? And does it go to the waste? Does it go to the recycling facility? Can it be reused? Can it be used for energy? And so one of the questions I had for you is, what are you guys finding for like, what is the proper approach that you believe is most realistic of what is actually going to happen to these mass timber panels at the end of their life?
So that's exactly right, exactly what we're doing. And so what we're looking at is the value of the material. So the idea now is that we look at timber as though it's basically a 4x2. It's basically a timber stud, timber framing, and at the end of the life, it's kind of like, it's got loads of screws and nails in it. It's covered in drywall, might be a bit kind of, and that's what we look at all timber generically as though it's that kind of timber frame, right? Piece of framework. And so what we're trying to say is, well, actually, you know what? When you engineer a piece of mass timber, it becomes a valuable product, and it becomes a product that people won't just throw away. They're not just going to chuck it into landfill. They're not going to burn it, because it's actually a substantial piece of material that you can pick up, that you can actually remill so that you can join it up with other bits of mass timber and you can make new panels, right? So that's kind of talking to the manufacturer, talking to demolition contractors, talking about actually even just, opportunities for maybe we don't buy the material from mass timber producers. Maybe as a building owner, we lease it. Maybe we lease the mass timber, and at the end of the building's life, when we're done with it, then the owner of the material takes it back and remills it. Maybe there's something there we can do, lots of, but also it's about the design of the buildings. So it's about designing our buildings with an understanding for disassembly. So thinking about how we can take the building down, thinking about how we can adapt the building, how we can remove elements of the building. And, so one of the things that we talk about in the office is this kind of, is how you frame success in architecture, right? So what we call success in architecture, right? And beauty is always an element of success in architecture. How well it fits into its context, how well it performs to its brief is all part of that success, right? But actually, we need to think about other elements of success now. Like an element of success needs to be perhaps not how tall it is or not how shiny it is or what a weird shape it is, but actually how easy it is to take to pieces, how easy it is to use those pieces again, and that actually that as an idea of success in architecture is something completely different from anything we've ever looked at before.
Yeah, that's like revolutionary. That's very
yeah. Do you know what it is? But actually, if you go this brilliantly, I was kind of one of those kind of apples dropping on your head moments. I was in Athens, and I was walking through Athens, and in Athens, just in the city, in the middle of the city of Athens, there's this beautiful, tiny little church, and the church is made of bits of stone that the Greeks had stolen from the Parthenon. So they'd kind of nicked these bits of stone from the ancient Greeks, and they brought them back down, and they built an Orthodox church out of bits of old stone nicked from the Parthenon. And I'm just thinking, when I was sitting there staring at that and thinking, we used to value the materials that we used to such a degree, that before we became this kind of throwaway culture, we thought so seriously about every element that we owned and that we had. We used to kind of darn socks and darn jumpers and kind of, and repair things and reuse things. And I think that, we've become this kind of culture that is obsessed with the shiny and the new and the kind of, and never having any patina or anything, never kind of thinking about the human experience, never thinking about the historical experience of an individual piece of material and all of that kind of thing. So I think it's about, when we talk about success, it's about reframing success and thinking about how we can celebrate those materials and their long life.
Yeah, I love that, because I think that a lot of, especially America, has this kind of like consumerism mentality, especially about architecture and building, and that materials are endless and will never run out. But
no, sure. Yeah, absolutely. I mean, you can see why that would be embedded in North American culture, because, you arrived somewhere 100 years ago or so, and there's all this natural material. There's in this vast expanse of kind of, of country and of rocks and of everything, you kind of just must have felt like that. So you can imagine how that would be embedded in the culture.
Yeah. Yeah. But I think, just getting back from Europe, when we were in Vienna, like understanding all the different architecture in Vienna and how long it's been there. And I mean, some of the buildings have stand longer than the United States has even been in existence.
Yeah.
And it's like the materials are still in use. So that's really cool that you guys are designing for disassembly and are able to take some of these components and reuse them in new buildings. I want to transition, Andrew, into something that we were on a panel on earlier this year at the Mass Timber Conference, and you were talking about this new componentized design that you guys have created specifically for London code, but it sounds like there might be expansion into other markets. But maybe you could give like a 5-minute overview of what the firm has been working on in regards to that.
Yeah, certainly. So it's what we call the new model building. And so we had this awful event in London 6 years ago, which was the Grenfell fire tragedy, where 72 people were killed, and there was this terrible fire event. And I think it made the entire construction industry, architecture industry in the UK sort of stop and take stock. And there was definitely a kind of a reappraisal of what we were doing as an industry in terms of building in timber and the combustibility of timber. And, we had some changes in the building code. Actually, they didn't massively affect timber, but they really affected perception. And so we had a perception, a public perception, a political perception, and a perception from the insurance industry and from the fire authorities, fire brigades, that actually, that we shouldn't be building at this scale in timber. And so as an office, focused on this method of construction, that was quite a shock to our system, as you can imagine. So what we did was to start to talk to the insurance industry, start to engage more closely with fire engineers, more closely with building code officials, and really to begin a conversation, which honestly, Nate, when we started the conversation, I think that I thought that it was going to be a process of education, that we would educate them and then they would understand, everything would be all right, and we could get on with it. But actually, as is so often the way with these things, you start that kind of process and you realize that these people, these individual professionals in slightly different fields, but within the same ecosystem, have an awful lot that they can tell you too. And you sit back and you realize that actually, we get, innovators like yourself, creators, artists, architects get very excited about new things, about opportunities for invention and innovation. You get really excited about these things, and actually sometimes it takes other parts of the same industry to say, whoa, slow down, mate. Do you know what you're doing? Think about what you're doing really carefully. Think about what the implications are. There's a lot of concrete buildings made of timber out there. There's a lot of buildings that are built, tall buildings made of timber, which is actually just, it's a concrete way of doing things, and we're trying to do it in timber. Actually, is that the right thing to do? Actually, can we, as an architecture profession, can we turn around? Can you, as developers, contractors, turn around to society and say to society, we know exactly what we're doing, 100%. Don't worry, society. As your servants, we are providing you with something that is completely safe, completely competent, completely robust. And actually, you know what? I think that there's a lot of learning to be done there before we can really turn around to society and hand on heart say that we know really what we're doing in those terms, to those strict terms. You and I sit there, we're building 200, 300,000 homes, with many hundreds of people, thousands of people living in them, sleeping the night there. The safety of those people in their beds is largely, a large part of that is our responsibility, whether it's direct or whether it's social. So actually to work with fire engineers, to work with insurers and warranty providers, to really think about these things seriously has been an incredibly rewarding process. And what we did over a 3-year period is working, I really stress this because it really was collaboration, is to design 30 individual details for a building, for a residential building, which we knew would be safe for both water, so flooding taps, flooding toilets, bathrooms, etc., and also for fire. So moisture and fire, that these were safe, competent details that we work through with fire engineers, with structural engineers, and with warranty providers, insurance providers, to ensure that if you build a building with these 30 details, then that is a safe building. And so we now have approval from the UK, the top insurers in the UK, who will guarantee that if the building is built like that, then they will insure it. We know that if you build a building with those details, you will get building code. We know that if you do that, you can get government grants for affordable housing using that type of construction. And this is not a kind of, it doesn't determine the layout of the building. It doesn't determine the facade of the building. So this can apply to any shape or any kind of like any kind of color of building. It's just, at the moment it's 6 stories, but we're about to launch into 10 stories. So it's just about, determining safety in those buildings. It's been an amazing process. So now that's open source. So that's available online for any other architect, developer, contractor to use. And we're talking to several different developers at the moment about building the first series of buildings like that.
Wow, that's awesome. Good on you.
Thank you.
So
we learned so much.
I bet. Yeah. I mean, it sounds like a very exciting, but also laborious process that you've gone through the last few years. But
yeah, it really has been really getting down to the detail. And the other thing, Nate, is we changed the way we drew. This is the other thing. Yeah, because what we realized is actually the way that we were drawing as architects was not actually transferring the information from ourselves to others in a clear way. Because architects, we draw for GCs, right? The GCs might understand our drawings, but actually insurance and code officials, warranty providers, members of the public, they don't understand those drawings. So actually what we started to do is to draw in a much simpler, much clearer, much more kind of illustrative way that people can really, really understand.
That's awesome. And so from your position with the code officials and the insurance providers, what was the response maybe first with the code officials that you got initially that you were speaking to in regards to you guys maybe coming in with a set kind of detail or way of doing it and saying, no, that's not how we do it? And what was the dialogue there to actually reach an agreement of, okay, we're going to publish?
So the dialogue was difficult at first, as I think you're alluding to.
Yeah.
It was pretty difficult. And it was, from my perspective at first, it was difficult because they were intransigent, because they had their way of doing things. But actually, the more I listened to them, and the more I realized how they take the responsibility of their jobs so incredibly seriously. And you realize that, and you realize that actually part of what you need to do is to communicate your intent better. And the other part of what you need to do is to listen to their concerns, address them, and illustrate them. So actually it became a really cooperative relationship, a really kind of collaborative relationship where I think both of us have ended up learning from it. And we did a launch of it, and all the code officials came, and we went out for beers with the code officials. And, it's really, you can't make an omelet on your own. That's not an expression, is it? But do you know what I mean? You can't, it takes a village. And the other thing that we did is that, we started the process by saying to them, look, the thing is, we all know that climate emergency is probably the single most important issue in anybody's life, right? And I say that with the full drama of that statement understood. Solving each element of this puzzle to put us back on track to live with our planet, is going to take every individual involved in every industrial ecosystem, So what I said to them is, this is, the job of reducing carbon in construction is not solely that of the architect. We're not some Jedi out there waving our lightsabers going to make everything. Do you know what I mean? This is going to take a whole ecosystem. So actually, you, Mrs. Insurer, and you, Mr. Code Official, you need to be in this room. You need to be finding ways that we can reduce carbon in construction too. It's not just my job. And the response that we got to that was, yes, you're absolutely, we totally agree.
Wow. That's awesome. That's really cool that you got that response.
Yeah.
And so the process of going through kind of from the onset of where we started, where they were maybe a little bit hesitant to approve this new building model, to where you landed up. what was your experience with the code official, the insurance providers? I think you said you were able to get some grants as well.
Yeah.
Walking them through and having collaboration to understand that this is a safe material. It's not going to burn down and kill people, right?
Yeah.
Because I think what we're all worried about, or we're worried about.
Yeah.
And so what were kind of some of those conversations and dialogues you had to maybe hear this?
Just walking each other through the testing, understanding that, a specific piece of code legislation is not, it's not a benchmark on its own. It's there for a reason, and it's unpacking that reason, working out why that reason exists, how you can meet that, what's the best way in order to safeguard that specific kind of proposition, to meet the concerns of that body of work, of that code official, of that insurer. So it really is just a lot about unpacking stuff, working out why something has to be like it has to be.
So if they said, hey, we need to have a 2-hour fire rating, you just had to go through and unpack what a char calculation is and
exactly what the plasterboard did. What do we do with a steel building? What do we do with a concrete building? How do they work in those situations? How are we comfortable in improving this? And it's really interesting. You learn a lot about kind of, insurance and what the basis of insurance, the notion of risk versus consequence, that we expect our buildings, somebody told me once, that our buildings, that the risk versus consequence of a building is 20,000 times higher than for an aeroplane, right? So we expect our buildings to be 20,000 times safer than we expect an aeroplane to be.
Wow.
So even though an airplane has 10,000 sensors in it, in a typical jet has 10,000 sensors, and a building has none. It's anyway, so there you go. I'm going to go off on one.
No, this is good. I think this is it.
It's really, it's fascinating.
Yeah.
Because when you get down to it, it's not a science, right? It's not about science. It's about society. It's about expectations of life. It's about expectations of safety, expectations about what society means, how much we can rely on society to care for us, to set standards which we all, rely on. So it's all about that kind of thing. It's all about unpacking that.
Yeah. No, I think
it's fascinating.
It is a really fascinating. And I think this is actually a good transition to my next segment about risk and challenges that you've had with mass timber. So outside of the new model building and going through that process to get those 30 details approved, what are some of the challenges that you've had, starting 20 years ago, and how have those challenges maybe been mitigated over the 20 years of experience that you've had? Maybe you could even start on that first cottage that you worked on.
Yeah. Well, you know what? 20 years ago is so much easier, because 20 years ago, it was all about a one-off, 20 years ago is all about, whoa, look what they've done. That's funny. Whereas now the kind of cat's out the bag and everybody knows that we want to transform the whole industry, right? So then people are like, oh, hang on a sec. What do you want to do? Why do you want to do that? How does that work? You know what? So you want us all to change everything we've been doing for 100 years, do it a completely different way. And this is the first example of that. And you're like, well, yeah, and then they're like, well, we're really going to go over that with a fine-tooth comb. If you told me it was a one-off, I'd have been absolutely fine with that. We'd have had some fun. But if you're going to tell me that that's a whole new revolution of a construction world, then no, I'm really going to look at that very carefully. That seems to have been kind of what's happened in the last 20 years. So it's just got more difficult as people have taken it more seriously.
Interesting.
And I think as we, as a practice, but probably more over the industry as a whole, have realized the specific potential of this method of construction, this material, this system of construction, the more serious, the more, the more kind of, the more potential that we show, the more problematic it has become to exercise that potential, because people, are taking it more seriously. So they're asking us more questions. So they're asking us about, how much is it going to cost? How much is it going to insure? How much is it going to deplete existing forestry? How much is it going to, how long is it going to last? All of these sorts of questions. So you I guess you just kind of like, what I encourage everybody in the office to do, and myself, is to never see these things as blockages, but just as, as hurdles, and when, you kind of, you jump them, you go around them, you answer them, you respond to them, don't ignore them, but don't kind of get, don't put yourself in a corner and just try and fight a battle, just sort of, let's always looking for solutions, not problems.
Yeah. Yeah. That's interesting that the bell curve has kind of been on the way up towards the end of the 20 years and not on the way down. And
yeah, it feels like it's, I feel like the new model building is a real turning point for us in terms of actually, we want to do one in the States. We're talking to the Dutch about it at the moment and to the Italians about it, to the French last week. So just the idea that we can begin to do something similar, that other architects, that other professionals take that on and to do something similar in so that we have a kind of competent working book. Because it really worries me. Architects are the worst, right? Because they just get hold of something that they see as being the new thing or fashionable, and they'll just run with it. And all of these tall buildings that people are coloring in brown and then telling their, clients it's made of timber, when they haven't got a clue what they're doing, is really not a good idea, because one failure and it's going to set us all back so far. And the thing about a climate emergency is you need to be dealing with it right now. It's not a climate emergency in the future. It's a climate emergency right now. They're not heat waves. They're not, whoa, that's an amazing storm. Wow, that's incredible. It's actually, we're in it now, right? And so we need to be dealing with it now. So in order to transform the industry right now, we need to be learning these things really quickly.
And so what challenges maybe specifically you could talk about around fire safety or the structural engineering or regulatory that you've seen from that first cottage? And as you said, it's gone up, it hasn't gone down. That maybe a good example is the black and white building that you just complete. What challenges did you run in there that were more challenging than your cottage 20 years ago?
Well, I guess, it's a much bigger building. You've got a bigger design team working on it. So actually that reduces a lot of those challenges because you're really collaborating with some amazing people on the job. So that, in terms of specific challenges, I guess cost and value is always one, to demonstrate to the client that actually the building was cost equivalent to a concrete building, which it was no more expensive than a concrete building, and it was substantially faster. We used, from the first drawings to the finished building, we used a third less timber than our first designs indicated. So just by careful designing through engineering and architectural iteration, we're able to vastly reduce the amount of timber that we used. So, we had all the issues that you're likely to have. We had an insurer who was going to, try and triple the insurance, but we sat down, we worked out with the insurer that they weren't worried about fire because they'd seen all the fire research that had been done. We had sprinklers in the building. They were really worried about flooding toilets and dripping taps. So we replaced all the CLT floor slabs in all of the bathrooms. We replaced it with joists and plywood because that's an established way of building. They understand how to repair that. They understand how to replace that. They understand the limitations of the damage that actually a leaking tap's going to cause on a plywood and joist floor, right? So we'll never put CLT back in the toilet floors again because it's really easy to do plywood and joists all the way down the building and it's less expensive.
Interesting.
Right? So there's kind of challenges that we're learning from as well. So it's not just about telling the insurers that they're wrong. It's going, okay, why? What would you like? What were you thinking? Where do you see the specific problem with that? What's wrong with the leak detection system? Those sorts of things, those sorts of conversations. So actually with this project, with the black and white building, we had a client who is a great innovator. We had a client who is, a really a kind of like wonderfully engaged person to work with. And so lots of the challenges that we have previously had with clients, and their, and their, I guess their kind of their appetite for doing something new we didn't get on this job. We just had the encouragement, the backing, and the enthusiasm of our client all the way through. We had to demonstrate cost equivalence for his investor, but we had, real backing for that. And now the building is worth 40% more than it was a year ago when we finished it.
Wow.
And the rents are kind of, 30-40% higher than they thought they would be.
So when they originally projected before you guys started construction versus when they finished, which I think was beginning of this year, they have a 30 to 40% increase in rents.
Yeah. And a 44% increase in book value.
44% increase. Wow.
Yeah.
That's fantastic.
Yeah.
You should get a bonus.
Right? I got breakfast.
Yeah, that's great.
So, I think that this realization, the understanding that there is value to what we do, that there is actual substantial monetary value to this proposition, as well as, social and planetary value, is something that is emerging, right? It's something that we're beginning to realize is that, those teachers and their pensions, those postmen and their pensions, those long-held investment funds, they want assets that are going to look great in 20 years' time. They want assets that are going to be appropriate in 20 years' time. They want, there was some amazing study that came out the other day. I need to find out who it was by, but it said they were talking about the psychology of climate change, and they said that that the majority of people think that they worry more about climate change than anybody else they know.
Wow.
This is something that bugs us all, right? This is something that's in all of our heads that we all think about. And so actually, when those pension funds, when the individuals making those decisions about about where to put their pension, when they're thinking about that and they're ticking the box that says climate friendly pension, they're making massive impacts into the work that you and I do.
Yeah.
Right? Because that's where those investment funds need to go. We need to demonstrate that those buildings are low carbon, and building in timber is a really visually clear way of doing that. These buildings are visually sustainable.
For sure. And so one of the things you said you had a demonstrate cost equivalence for the black and white building for your client.
Every project that we've ever done in timber, we've had to demonstrate cost equivalence.
So tell me what the process is for you doing that. Do you design a full concrete building or steel building and cost it out, or how do you do it?
Yeah, we assume the same level of services. We assume the same, external wall. We assume, other kind of things within the building itself as being exactly the same, but we replace the timber structure with a concrete structure, notional concrete structure, and we cost and we schedule that out.
And what is your typical findings? Is wood more expensive, less expensive?
Do you know what? It's always a little bit more expensive. It's always a little bit. It's always maybe 5%, 2%, 5% more expensive, right? But it's faster. And so the speed of your construction makes up for that small additional investment. And you know what, Nate? I get every time the price of concrete and steel goes up, I'm like, yes, fantastic. Now nobody's going to give me any knockback. And then the price of timber just goes up by exactly the same amount. And you're like, and I phone up the timber manufacturers and I go, why is your timber prices going up? Is it because the concrete and steel prices have gone up? You think that you can just track your prices against them? And they go, oh, no, Andrew, we'd never do that, mate. No, we'd never do that. No, it's just been really windy, or the roads were really muddy, and so we had no choice. But they're not stupid, right? They're smart. They've got this still relatively limited commodity that builds better buildings faster, right? So they know how much it costs to build a concrete and steel building, so they just make their material a little bit more expensive. It's like the insurers, right? The insurers, they know these buildings are worth a bit more, right? They know that actually, if you're a person that's building a building out of timber, then you're probably really enthusiastic about it. You're probably really excited about it. And so, hey, maybe I can get an extra 10K here or there, maybe I can layer on a little bit, and they're so excited about it, maybe they'll kind of give me a bit more cash.
Yeah.
So everybody comes to the party,
Yeah. It's very opportunistic finance.
Oh, well, there you go, America.
Yeah, exactly. It's actually interesting that your stat aligns with mine, because we just got our study back. We're working on a case study for USDA, and we're looking at our building in Madison Baker's Place. and comparing it to concrete and steel buildings. And Baker's Place is a hybrid. And so we just got our study back looking at a full concrete, and we were at 2.8% increase for our hybrid structure.
Yeah,
so, which I was quite pleased with. I was thinking it was going to be like 8 to 9.
Yeah. No, it's pretty, you know what? And I bet the timber element of that was probably about 18% of the entire construction value anyway.
I don't have that off the top of my head. I think it was close. I think it was like 20%.
But you know what I mean? It's not like, I mean, when this is the thing that we find with cost and timber buildings is that anything that, you know, when you build a building, there's always a specific constraint to that site or to that brief, you know, which, you know, you might be building above a sewer, or you might be building next to a cliff, or you might be building on a main road or by a rail line. Do you know what I mean? And that additional cost, you know, you can bank on it. The contractor, even if it's about something that's got nothing to do with the timber at all, the GC will come around to you and go, yeah, it's the timber, mate. You know, if you hadn't have done it in timber, if we'd done it in concrete, it would have been fine. You know, really? Well, they would have diverted the sewer for us if we'd done it in concrete. Do you know what I mean? It's just like, so it's always the new thing that gets the blame. So you just have to work it out. You have to make friends with cost consultants. You have to make friends with, you know, with people that understand how those particular levers work and get the knowledge. And once you've got the knowledge, then you're armed with the power to be able to make changes.
Yeah. Yeah, I think that's what the industry needs more of, is just more knowledge and transparency when it comes to the actual true cost of timber versus alternative materials.
Yeah. And also you just need to build more manufacturing plants and have more timber. I mean, you know, at the moment in the States, we find it's absolutely crazy. If I want to build a building in the Northwest, in the Pacific Northwest of the United States, it's less expensive for me to import the timber from Austria, right?
That's exactly what we've gotten too.
I know, and it's bananas.
Yeah, it is bananas. I really don't understand it, because it's like we have so much wood in the U.S.
Yeah.
And we actually have a few manufacturing facilities.
Yeah, but actually, you know what? By mid next year, you'll produce as much mass timber in the US as we do in Europe.
Really?
Yeah.
Well, that's fantastic. That's actually a good sign.
Right? Sure. So about 1 million cubes each, right? And so, you know, give or take a little, you know, probably Europeans maybe will open up a few more plants that'll skew that a bit, but it's really close. And yeah, you know, because the enthusiasm for mass timber is so rampant at the moment in the US, you know, it's hard to make that kind of hard to kind of, you know, not to kind of get that cost inflation, but it will settle. It'll settle down, and there'll be more manufacturers come in.
Yeah,
you know, you look at how much you're losing in, you know, this year, 2023, Canada lost 5% of its forest cover, you know, from fires. If you built with 20% of that timber that was burnt, if you just used 20% of it for timber, you could build 84 million homes.
Wow. Just out of the 5% lost of forest from the forest fires this summer.
Yeah.
You said 84 million homes? Wow. That is crazy. I mean, what do you think about like long-term forest sustainability?
And if that figure doesn't work out, then I'll find a student in the office who calculated it, and I'll give them hell.
we can cite our source later. It's from Andrew Waugh. But I mean, what do you think about, like, how does more mass timber and more mass timber buildings affect our forests? Because I know for a lot of people that aren't practitioners in the space, they think, oh, you're cutting down trees. That's terrible for our environments. Why would you want to do that?
Yeah. And this is a conversation that urgently needs to happen, right? This is an issue that urgently needs addressing. And yes, in an ideal world, you wouldn't cut down any trees. You'd let trees burn naturally. You'd let trees decay in the forest, you know, and you wouldn't plant trees, right? They just would naturally occur as they have done over millions of years, right? But we don't live on that planet anymore, right? Because there are 7 billion and counting humans. We need to interact with every element of our planet in order to be able to, you know, create an environment where biodiversity can thrive and that we can thrive too, okay? And so to sustainably manage forests, to plant forests and harvest them and replant them is going to be part of our future. If it's not part of our future, then the planet is going to be in even more trouble than it's in right now. You know, if you don't allow people to use those trees to reduce the carbon burden, then the climate emergency is going to be exacerbated. It is going to be worse, and the biodiversity will suffer more. So there needs to be an attrition, there needs to be an understanding between the people that feel protective over our environment, which I myself do, and the people which, you know, who are seen as being the people who are degrading that environment. There needs to be an understanding that we are faced with a stark choice, you know, and we need to plant more trees, you know, and we need to stop burning our timber. We need to stop using it for fuel, right? In Europe, 60% of our sawn timber is burnt for fuel. It's crazy. You know, timber in the forest, if you cut it down, it's subsidized as a fuel and taxed as a construction material.
Interesting.
Right? That's insane. That's
that
bananas, right? So that needs to be changed. We need to totally reinvestigate our relationship with all things natural, but that doesn't mean not utilizing them. It means utilizing them preciously. It means thinking about how we can reuse them once we have taken them. You know, so all of those sorts of things. I mean, that's why for me, the kind of the ethical part of this life cycle study, that we're carrying out on timber at the moment, this reuse, is really part of an extended ethos in terms of how we touch the ground lightly, how we respect and think about the materials that we use.
And do you think that when we use more mass timber and have a really good long-term demand of mass timber from more mass timber buildings, that it will augment people to maybe go back into forestry and go back into sawmilling and
absolutely
a bigger ecosystem?
Yeah, definitely.
Buildings.
Yeah, absolutely. I really think so. I really hope so as well. To kind of, you know, I think that the more people that have a closer relationship with nature as well, the better for the future of our planet. But I also, you know, want to stress that performing this sort of exercise, this transformation in architectural construction that we're talking about in Europe and in North America, we're just scratching the sides. We're so peripheral here. 90% of development, 90% of construction that's going to happen in the next 20 years is going to happen in sub-Saharan Africa and India, right?
Really?
So what we're doing now in Europe and in the US really has to be part of a briefing exercise for the construction future of those countries. So that's what we need to be thinking about, you know, because some, you know, pretty little building in the middle of London, you know, or a lovely apartment building in Wisconsin is not going to solve the climate emergency, right? We're doing our bit. We're part of the solution, not part of the problem. Fabulous. Maybe we can sleep easier at night. But actually, if you want to talk about actual solutions, then it's going to be about reducing global concrete use. It's going to be about reducing our global, dependence on steel. So that has to be, I mean, I think for us as a practice, it's always in the back of our mind, you know, how can this technology be easily transferred? How can we promote the notion within these more developing economies that actually that doesn't have to, you know, they don't have to go through the same history of industry that we've been through. They can make technological leaps based on investments that have happened in Europe and in North America, right? So I think that's really, that for me, that's the exciting thing. That's the future. That's, you know, where we need to be working, where we need to be thinking.
And is that why, and one of maybe the impetuses of you building this new model building, of having these details already prepared, already sorted out, so that you could take these to Africa or India or other markets and they would be able to use them since they've been vetted in the UK?
Absolutely. Yeah, absolutely.
It's really cool.
Yeah.
That's awesome.
That's absolutely the ambition.
Very cool. Well, I know we're up on time here, Andrew, but I was very impressed with the interview. Excited to
Thank you very much. No, I really enjoyed that, actually. Good questions.
Yeah. Lovely questions. I think as a closing note, Andrew, thanks for coming on the show today. And where could our listeners find you guys and some information about the new model building and the LCA work that you guys are working on at the Waugh and Thistleton office?
Thanks, Nate. Yeah, definitely. So check out our website, which is waughthistleton.com. and Instagram and LinkedIn and Twitter under similar names. So yeah, please get in touch, collaborate in any social media. Yeah, be part of it. Join the club, because we have, we rely on questions and collaboration for new ideas, to help with new ideas. So that's
awesome.
One part of our practice.
Well, thanks for coming on the show.
Brilliant. Thanks, Nate.
Have you here.
Yeah, good to talk to you.
At the Neutral Project, we're not just building structures. We're building a legacy of sustainability, helping align your investments with a sustainable future. We'd like to thank you for being part of this conversation. For more information and to stay up to date on how we're reshaping the future through environmentally conscious development, visit our social media accounts or our website at theneutralproject.com. Thanks again for tuning in, and we'll see you next time on the Neutral Podcast.